Start recording. Let's go. So here we
So
are.
what it okay, so explaining what's going on there. A, do you agree that A is possibly many solutions?
Yes.
In that case, well, it's not really, but it's you only have one solution that actually is constrained on the first element, right? So
Uh
that's
huh.
the definition of equality.
Uh huh.
Uh, but if you had like a list, for example, then it would be well. If you had two more possibilities, that's my point. The value of A could be bound by two other different that's a principle of non-determinism, right? In Prolog and etc.
Mhm.
Uh, the thing here is the data structure that we have is giving us a set, like a list, with us. Well, I should say actually a sequence, right? Don't know what it is. I don't remember now, but it gives us a sequence with possibly multiple bound solutions. In this case, it's just giving a sequence with a single value, which
Wait a
is
moment.
that one.
Maninho, did we implement what Mageta just said?
That works inside of a predicate, but right now, when you run a query, it only gives you the first result.
Ah, okay. Because I was pretty sure we have a string to a string. We have this in there. Because my Mageta is modeling as this.
Well, it can be things like
Um,
yes, that is true. Yes,
Yeah, so I
it's
think
it's the
our
name of two.
compilation mode only does this and only does the first one, which is wrong, but just for us to be on the same page.
Okay.
Go on, Mageta.
Yeah, but that is right. It's a tuple with so on the second tuple there is no header. And that cringe library that I'm using requires you to have a header. I tried to I forked it and I was looking in the source code
I
to
think I
see if I
saw
could
that.
alter. I spent like an hour on that and I gave up. It was too painful. I think it's better to just use like a C library and
Have you
do
checked the
FFI.
issues of the library?
No, actually, but the library is
uh,
very new, so maybe that's the
I
reason.
have a question actually.
Yeah.
Go for it.
That one is inside of a list, right?
Uh,
Yes.
As far as the
one.
printing is concerned.
Yeah, I mean the list is the list of solutions. Yeah, that is right.
Why is that? Shouldn't we have like a table with the variables, one variable per column, and then each row is a potential solution that binds all variables, right?
Go to the code lemons. I think it's easier to look there.
Let me share the screen differently. Go.
Hopefully, there's no work there.
No, no, definitely not. So we are talking crawler. There we go.
Yes,
Tabulation.
tabulation. Which, by the way, anyway, I don't need to say how I hate this, right? Um,
Well, actually, not really. These two functions, inspect list, are different per module.
let me explain what I wanted. Scroll up, all the way up.
Scroll up.
You see that signature?
Yeah.
What I wanted to do is enforce a type that you can adapt given the given the multiple implementations. So you can go to std out, I don't know, the wire like network, whatever, right? You just produce whatever is necessary for that. So
Yeah,
your
I tried.
variables can be
Like I
propagated.
saw this to do. Well, I rephrased it, but I saw this to do that you wrote for with that intention. I tried, but the problem is that all of the smaller functions, such as inspect list and inspect, they are different per implementation. So
Yes,
I
but
can't just use that, you
yeah,
know.
but that is my point. Just don't expose them. That's why they're not on the signature, you
Yeah, I'm not
see?
exposing them.
Yeah, but my point is that you can't just use the same implementation. I think that's what Marine West on the thing. If they're not exposed in a signature, you can't just use them on something that implements the signature. So that made the code duplication because the other thing is out of the signature. You see?
Yeah, no,
So
but
the
these are
correct
different.
approach.
That's why it's not duplication. This is
Mm,
different.
no, my concern when
mm,
I made that comment was okay, there was this code and it was not inside of a module.
yes, which is
Then
down
Magetta,
there.
Yeah, then Magenta put it in a module, and he made another module that has the same signature because he wanted to print the tables on the terminal, right?
Yeah.
Yeah.
But then at some point, when you had to solve the merge conflicts, perhaps, or
Yeah,
I'm
yeah,
not
yeah. He
sure when
duplicated
exactly.
these two functions down there outside of a module.
Yeah, because Lemos had made a separate PR that got merged in the meantime that was changing those functions, right?
Yeah, I
Mm-hmm.
was changing them. And then Magetta hated my soul and just pasted them down here.
Curse your house.
But I already fixed that. It's already fixed.
I mean, we should still revisit this later, because my intent there would be to just have a. Well, we're not reusing things properly, and I think there's still a couple things that we could reuse. Although, as you pointed out, the inspect list and the inspect
Are
types are
different.
different,
They are
right?
different.
But we can still improve a couple things. But
No, there,
anyway,
no,
like
there's
ignore
always
this
room
for
for
now.
improve.
Uh,
Yeah,
Focus on the
actually, there is something that I want
tabulation.
to do in this file. It's great that because well, I saw that, for example, you implemented for the tabulation this function, but you haven't implemented this one. And in
Yeah,
my infinite wisdom, I decided that okay, I'm just gonna make a dumb version for Magenta for free. But I think it's better to just have a fail within here.
possibly like not implemented.
Yeah,
I mean,
exactly.
yeah, whatever. Just don't use it, right?
Yeah, so
That's
I
the
just
idea.
say like literally fail with query
Uh,
args is not implemented for tabulation
okay.
because it's less
Cool.
misleading than what I did. Anyway,
Yes, that makes sense.
so this is
Okay,
the
so
problem here. You see, Marinho, this is the data
yeah,
structure that Marinho is using. So he assumed very wisely that we were doing a variable name and a list of outputs. The problem is that we're not.
Um,
and then when it gets converted, it's still a list, right? Because I don't know what are the variables. So in that case, it is only one. We can fix for that example and put a and flatten it. Uh, but let me just think. If we have more, can we come up with an example where you have two possible answers? Let's think of one.
um, sure. So many
Um,
answers.
I think maybe addition.
Which type of addition?
Like, okay, addition no, but maybe like, but then can we do unification of like multiplication?
Yeah,
Because then
sure.
you can do like, okay, so you can do power, and then you do what number is equals to. Well, it's like an equation, right? So what are the roots of a polynomial that is squared? It's the same
we don't have
number.
Oh,
we don't have proper constraints though.
Well, then
Like if you try to do a multiplication and you have two unbound variables on that multiplication, that just fails because we don't have value generation for that case yet.
oh, we need value
hmm,
generation to do what Magget is asking.
I mean, unless you have two variables specified in the multiplication, you can't really figure out the third one, right?
Ah, yeah, that's true. That's actually true. Okay, so you're gonna have to wait for that, Magget, because we don't have value generation.
No, but look, you can do this, okay?
maybe like two predicates, right? Defined like color, blah blah, and then you
I
just
think
ask
Marinho is
what is
writing
color,
something as
blah
we
blah.
speak.
Yeah, but let me write as
Look,
well.
just look, you're overthinking things. Just do this. Problem solved.
Yes, exactly. That's exactly my point.
Okay, so that's not.
Like tags, anything works.
Okay, so let's first compile this program to see if it should work. So compile examples many answers. Oh, now it's tried to do tabulation for some reason.
So
Wait, but that doesn't
so
make
that is being
any
called
sense, right? Why is
cursor
it
house
calling this?
lemos.
Query args
Nobody
is
is
not
calling
even.
this.
Well, something is clearly calling it. Oh wait, it's a single element, right? So
Yeah.
it's summoning the fail with. That's why. When you open the module, it summons that, it tries to evaluate that thing,
But
right?
this is a function. It can't figure that out by the
It,
signature?
well, it's not a function, it's anything, it's a value, right?
Well, okay,
It,
so it can't
yeah,
figure that
yes, the
out?
value of the, I mean, it tries to evolve to bind the value of
What
the
if I
function.
give it a type?
I have a
No,
question
man,
actually.
the problem is not the type, man. The problem is that when it will assign the value, it will try to assign the body for that object. And the body needs to be evaluated in a with.
But it can't evaluate this because this is a
Uh,
function.
Lemos, I have a question actually. Why is query args not implemented? And why is actually part of the signature? It shouldn't be.
Oh, it's because query args is needed for the standard output.
Query args will be needed regardless. How else are you going to figure out which variables you're supposed to print?
Because query args is not required for the tabulation mode because tabulation mode is only used for in the REPL.
Oh, wait, okay. So the tabulation mode was query args before, right?
But
I think you moved to query string.
when you put a query in the REPL,
Man,
you
the
are going
proper
to
way to do this would be
print
to put
the
the.
arguments, right?
No. Marinho is
The
confused. The
variables.
library generates a complete full string for it, Marinho. We don't give
No,
it the map. We just
but
give it the
that's
full constructed string.
but that's how are you going to figure out the constructed string if you don't know which variables in memory you're supposed to look at for the
Oh, you're
values?
assuming that this function uses query args. It doesn't. Only mine
If,
does. You're basing Mageta's implementation on mine. That's not how that works.
but if it doesn't use query args, how does it know what to print?
Well, it does. It does this fold. Like it does a couple of things actually. It creates this folder function that calls inspect, for example. And inspect, if you remember, is being called in my query args, right? Query args calls inspect on mine. And then instead of like I could, okay, let me be fair to Mageta. I could have rewritten this, okay, Marina, to
Man,
put this folder and this fold in here. I could, but I didn't because I was lazy.
the proper solution is both should output query args alone, and
What is the
then you
value of
have
this?
a.
Go on,
What the value
Mageta.
of.
Go on. No, go on, Mageta.
Both output the query args, and then you pass a functor module that you define what is the type of the return of that thing, and then in one you can format as a string and etc. You see,
I'm extremely confused. Could you
you
repeat that?
pass in another module that implements the conversion of the query args from uh, to whatever output you want, like how to print that. You see?
How to
That's
print?
but that's not what query args does.
Yeah, no, okay, let me explain to Mageta because he doesn't know. So, why did I rename it? Let me explain that. Because for the testing suite, I needed a way to just have a simple mapping there. Because I didn't want to rely on standard output for the tests, because I think that's overcomplicating things for no value. So, what I decided to do was, I'm going to make query args just return you a list of pairs that tell me for
I
this variable, this is
wait,
the.
wait. Give me a sec, man. I don't think we're talking about the same thing. I am just talking about what is the. Like, I understand that you have to have the structure, right? The data structure to do whatever with it. I don't know what you guys are doing with it, but you need the the structure. I
Uh-huh.
named it before query args because that was the printing thing that was on the REPL.
Yeah, I
So
just
far,
grabbed it and renamed it.
yeah, and you renamed. Cool. That's it.
Yeah, but it's exactly your code. This is exactly your code. But Magetta, I think we can do what you want. We can extract this portion to be query args, can't we? Look at what Magetta is doing. He's creating a batmap out of, and he's calling it vars. And this is suspiciously similar to what I am doing. You see?
But why would you want that?
Well, because this is
Because if you
decoupling the concatenation of things from the actual map of things.
No, that's fine. I understood that. But why would you want that now? That's my point.
Oh, just because right now what I proposed before was okay. Just make this a fail with because for tabulation we don't
Oh, I
need the
see. So
query
you want to
args.
break. Okay, then go for it.
Marinho?
like I'm just confused like if in both cases you need a map of label to the variable that you're going to inspect to display to the user, whether you print it as a string or as a table, doesn't matter, right?
Mm-hmm.
Why is it part of the signature if the implementation is the same?
Which implementation?
Well, the implementation of building the map by inspecting the memory so you can know, okay, I have to look at this address to
It's not the
print
same.
this variable.
Look at this type. Imagine that it was a map, okay? It would be a key being a string and a value being a list of strings, right?
Uh, well, technically the map that we are using is a map from label to memory address, but each memory address can be bound to potentially many results, although currently we only grab the first one. So,
Sure, but I'm not doing what you said as well. This is not this map up here. It's not a string to a variable address. This is just a going from map to map.
variable map, variable value. The value is a string as well. Why?
Yeah, this is because that's what inspect does. I don't know if you remember, but when we created inspect list and inspect, they actually stringify everything. That's what they are made for.
Hmm.
So what I'm doing here, which is actually in retrospect, Magetta is more correct because he's making a list of strings. I'm just making a simple first one. You see? So they are not exactly the same, the query args. So that was one of the reasons that I didn't bother to extract this portion of the code and put it in here, because Magetta is doing a string to a list of strings, and I'm doing a string and a string in here. So in order to fix it, I need to rejigger, like re-engineer the code for stdout to also use a list of strings in the value instead of being the first one.
Ah, right, because actually the original query args was calling inspect. It wasn't just doing a simple crawling of memory.
Mm-hmm.
It was actually building the string as it went.
Yeah, it's still doing that. This version. It's literally creating and concatenating the strings as it folds. But we are doing just the first solution, remember?
Ah, I see. Well, I guess we can leave this for later then, because we'll
Yeah,
have
it's
to
going to take some time.
do. Yeah, this is gonna take some time.
Yeah, but I wonder if this fixes the problem. It doesn't. Magetta is right. So I'm so disappointed right now. This is a
And
function.
when I say evaluated is that OCaml needs to have it's strict, so it needs to compose first what the function is, and then when it tries to do that, it's fail,
So I need
right?
to do this.
Yes, you can delete.
Okay, that's
Uh,
okay.
you
Only
could
one
have
answer.
done that with a argument as well, but okay, you didn't need the lambda.
Yeah, if you flip the clauses of the main
It's gonna be the two, right?
facts, it's gonna print the two because it goes from top to bottom.
Yeah, but okay, so we don't have multiple answers. That's what you're saying.
Yet, we don't have them yet. They do work if you're inside of a predicate, but if you're pulling them from a query, you can only get the first result right now.
How much work is to make that happen?
Uh, we would need to do backtracking of the query itself.
That sounds a
Is that
lot.
hard? Oh, we have the backtracking function. We already
We
have.
have the machinery. The problem is we need to. We would need to. I wonder if it's just a case of setting up a backtracking point before the query. That would need
Okay,
to change the code generation, and this
okay,
could
let's vote.
be.
Do we want to do that today or do we want to continue doing the modules?
Uh,
Uh,
honestly, I'd rather do modules today.
Like it?
just finish what we started.
Okay, so let's just, oops. I'm not gonna put this example right now, but I will commit this change. So, um, update query args on tabulation to fail with instead of mislead, to fail with. And then we can say otherwise the implementation would mislead the programmer to think something was implemented properly in there. That is not true. That was always not true. Okay, can you finish reviewing the PR, Marinho, so we can merge this PR from a Git? I would review it myself, but I made commits to it.
Okay, I can look at it. Just one moment.
Yeah, but Mageta's idea is actually a good idea. Like, if you, because in the future we're gonna have the wire here, because we need to send the AST to the engine. So yeah, that's actually a very good idea. The crawler can like crawl into the memory, but codify it in a different way depending on the case.
Yeah, no, we need to abstract over the output type to make that work. Because right now, I think the outputs are hard coded, right?
Yeah, the
In
outputs
the
are hard coded.
signature.
Yeah, they are. But that's not a bad idea. That's not a bad idea at all.
Okay, let's see.
Awesome.
Files
Awesome, awesome, awesome.
changed.
So, doing tests. Let's just see if this is still okay. Yeah, it is. I'm so proud of this now that you have tests. Like, we don't have error messages, but we have tests.
Who needs error messages?
You figure, just don't write bugs, am I right?
Just don't write bugs, yes. And the fact that I unironically heard people telling me that in the workplace is just insane.
Yeah, no, that's completely
And like,
uh,
were they telling
unbelievable.
me to write bug-free software with like proof languages? No, they were just telling me not to write bugs.
I
That's it.
found this the other day, by the way.
Don't write bugs. Maybe that was the article.
Maybe it was a reference all along.
I want to believe it was. I have my doubts though. I'll be right back.
Okay.
Uh,
So I'm waiting for your approval, Marinho, so we can do the
Man,
thing.
we have proper subcommands now.
Oh yeah, which are very disappointing. The way that I had to do that, like the Haskell library is like 10 out of 10 in comparison to this, but it works. And there is also the disclaimer that it may be a skill issue on my part. I haven't spent a lot of time reading the library docs. I just wanted to make it work.
Command groups root info.
But in my experience, spending very little time on Haskell CLI library as well, the Haskell one is better.
Man, this thing um, generates a proper like man page
Oh yeah,
formatted thingy.
oh yeah. It gives you a lot of flexibility.
Hmm.
I just don't like the way that I need to disperse all of the command line things to make it like improve it. Because before it was a gigantic file on the main, and that I didn't like that. So I decided to make like a directory and files inside and stuff. And I actually had another idea that I haven't implemented, but I was thinking about it when I was working out. Man, just look at my screen for a moment here. I was kind of thinking that maybe in the future it makes more sense to just have like, and then in here you say, you know what I mean?
From clauses and from file.
Yeah. And then later, I think we're gonna have this need in the future.
Oh, I mean separate the stages.
Yeah. You can call a compilation, but the input type can differ. And you have total flexibility on which stage you want to apply the pipeline on. If you already have parsed the file, good, you just call from clauses. If you have parsed the file and preprocess it, you just call from preprocessor.
Uh, can't
Because
we
I had to
kind
do
of
a
already?
very, I had to do a thing that I'm not particular. Oh, this is the compiler. What am I doing? This is not the correct place. My bad. This should be in the executor here. Yeah. So I was thinking about that because I had to implement this compile prime function.
Okay.
And the compile prime function is essentially like you grab a state that already exists, you grab the extra program, and you give me the final states of the VM. So this would be like continue, for example. So it would have a continue here, for example, right? And then we have the compile, which could be from scratch. And then I also had to do that for the load. I have a load prime. I had the load declarations. I have continue. So I was kind of thinking that we could separate in separate modules and have separate functions from which stage you want to apply the transformation on, in this case compilation.
Hmm.
And then it's going to be executor, compile, from file. Well, what do you think? We're not going to do this right now, but I had this idea in my head.
Ah,
And the types won't be these, right? It won't just be a bunch of units. It will be functions, but I'm lazy.
I mean, we can do that. I think we will need to do that at some point.
Yeah, definitely not now. Like for now, what I did is completely reasonable in my opinion. But we will definitely need this in the long run, I think. But that's only an idea that I had.
Yeah, we can figure out the details later. But yeah, that seems like something we should do eventually. Uh, okay, let me finish reviewing. Pa, 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 pa.
Well,
Turn it
can you
out.
review and talk at the same time, or do you rather just focus on reviewing?
We can talk as long as you don't ask me to watch your screen, because then I'll have to stop looking at the
No, no, no,
code.
no. I'm not gonna ask you about things on the screen. I want to know how can you make functors if modules are not values.
You can name modules, right?
You can name them. Sure.
And you can refer to things by their names, right?
No, the names need to refer to something stored somewhere else. Agree?
Well, yes, they will exist at runtime, but only at the runtime of the compiler. They don't exist at the runtime of the language. That's the point.
But that's the thing. If the modules are gonna be the compilation unit, we're gonna have to compile the modules, no?
Yes.
So they will exist outside of the runtime as well.
No, 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 but they won't exist as a module. When you compile them down to like bytecode, you just have a blob of code that you can run, and you have different entry points, right? But you can't really refer to that as a proper collection
No,
or
but that's the
data
thing.
structure.
No, that's the thing that I'm talking about. You just said they are a blob. So in order for them to be a blob in binary, they need to be in the memories in the VM's memory, right? Somehow.
Yes.
Okay, so we need to have at least some metadata information about the module in the memory now. No?
We need to know the entry points addresses, basically, and
Not only
arrays
the
as well.
addresses. For example, the name of the module, for example. I think we need to save that somewhere.
We we kind of do, we kind of don't. Depends on how we do it, but um, depends on how we do it. But yeah, we
Well, we
will need
could
to have
actually, in
name.
retrospect, we need to, but we can use the name of the file, right? Because you're gonna have a collections.karuta file. Okay, now I want you to look at the screen. Um, when you are compiling, for example, to use as a library, you're gonna have what? Lists.o and msets.o. These can be the names of the modules, right? These things.
Yes, but only if you are willing to have global names.
No, but not necessarily global, right?
If you say, okay, the name of the module is the name of the file exists outside of the language, so the name must be global.
Or we do it like this.
Uh,
Nah, this sounds like optimization that is too early. Let's not focus on that right now. But yes, but we agreed on what I wanted us to agree. We need to say we can refer to things by their names, but they need to be somewhere. And I thought they would be in memory somehow.
I mean, eventually, code, the compiled code of the module needs to go into the virtual machine so it can be executed.
Yeah.
Um, but it's not a first class value in the language. Like you can't bind it to a variable, for example.
Ah, that's your definition as a value, being able to bind it. That was not
Like,
the
can you?
definition I was using. I was using as in the sense that you can find it in memory.
No, that's not what first class means, Lemos.
No, but I didn't call that. I call it being a value.
Uh,
Like for example, constants.
well,
Constants are
a
values because
value.
you can literally find them in memory, right?
Not necessarily. They can be directly in a register, but
No, yeah,
you can bind them to variables. That's something you can't do with a module in Karuta right now.
yeah, no, it's gonna be it's a directive, so it's not a value in the sense of being able to bind. But okay, I guess it was my fault. I didn't specify what I meant by calling it a value. But I was basically thinking of set constants essentially.
Set
Yeah,
constants.
because when you have a piece of code that is not using the constant in a register, you're using in a like for example in queries, for example. When you look at the generated code, there's literally a set constant in there with the raw value of the constant. I was kind of thinking, okay, this is what I'm this was what I was calling value before. But I think your definition makes more sense, being able to bind it to a name. Then that's not true in Karuta. No, it's not true in OCaml as well, as far as I know.
Uh, it kinda is, it kinda isn't. The problem is that modules have a separate namespace in OCaml, so they are not quite first class.
No, but they will also have a separate namespace in ours, right?
Yes, and that's part of the reason they are not first class. Like you have
Yeah.
like you can't refer to it as a normal value in the language. You can't bind it to a variable. You can't put it in a collection. You can't really do the normal kinds of things you expect to do with an arbitrary value.
Mhm. Mhm.
Inspect list. This is basically the same. Oh, but this returns a list. Okay. Mm, yeah, this looks okay. This looks okay. We have an executor now.
Oh yeah, we do.
We
There's
can
a bunch of
sentence people
strings.
to death.
Oh yeah. That would actually be a perfect way to make the presentation about Karuta funny. Like, you're explaining the runtime of the language, and then you just say, and then we call the executor, and then you pass to the next slide, and it is a guy with the 300 movie slicing the head of the guy. That would be funny.
Um, parse option. Hmm. Let plus. Yeah, PPX is something I don't really know that much about, unfortunately.
Oh, we're not using Let Plus though, so there's no need to
Aren't
get to have this module. Yeah, we were
you mean?
before. We were
Oh,
before.
I see. I see.
And now I don't have to test an example in particular. I can just call all the tests and fuck it. PPX is basically a preprocessor thing.
I'm aware of that, but I don't know all the details, like
It
what can
sucks.
you do with it.
You can do a lot of
Um,
stuff. You can do a lot. But like they are not the best thing, but it was an afterthought anyway. So remove unnecessary um, redefinition of option module in executor. There we go. Removed.
nice. Refresh.
We're not using to option as well. Damn. Oh, I was using to option at some point because I was using bind instead of a map. Okay, this also can die. Thank you. I love removing code
Why did we have this separate list module redefinition?
because I implemented to option, which doesn't exist in the vanilla one.
Okay,
Uh, I kept the typo. I typed the module wrong twice. It is what it is.
amazing. Um, compile dash, compile prime
Ah, wait a
actually.
moment. There is a stashed thing. Yeah,
Eval,
there is a
compile
stash thing.
endpoint.
Fix the bug of saving queries from previous query variables from previous queries in REPL. I forgot about that. It was in my stash.
I see. Uh,
Well, I don't think we also need to put a lot of attention into the REPL code right now because it's just a proof of concept anyway. Like I think
loads many
Magenta grabbed the code
defaults.
from somewhere and I haven't touched it
Continue.
myself.
Update store.
Yeah, and I also moved some functions to proper modules, as you can see.
Verify. Why are we rejecting empty files?
Uh, we are rejecting empty files.
Isn't that what this does? Like verify file path takes a parser clause list and it fails if the list is empty.
It doesn't fail.
Or rather, it prints end. Wait, why does it print end line?
It's just to communicate that you cannot parse whatever was there. The error handling is being done by the people that call verify. This
But
is just
that
for logging.
means,
This is just for logging.
that um, am I in the right branch? No, I'm not. REPL verify. And this is called in the executor.
Yeah, it's only logging after the parser is done.
I see. It's basically just notifying the user that hey, you gave me something that's empty.
Well, yes. Not necessarily empty though. right? It depends on how the parser behaves exactly. But I just put it here just for logging purposes.
Okay. Okay. That's perfectly fine. And then there's the interpreter. Yeah, this is the code that Mageta copied, I think.
Yeah, that one is the one that I haven't touched myself, so I don't know how it looks and how good or bad it is.
It's using lightweight threads um,
No,
to
that much I
do
knew.
input. And it's using a class for some reason.
Yeah, don't ask me questions about it. I have no idea why or who or when or where.
Yeah, this looks okay. Approve.
The only thing that I changed was the program loader because it needed to receive the arguments from the command line. That's the only thing that I did. Okay, you approved. So let's go for a merge and let's fix your branch now. Please share the screen and I will stop sharing mine.
I can, and just let me. Did you merge already? You
Yeah.
did. Git pull origin master.
You're probably gonna have some conflicts, I imagine.
Uh, yeah, you have conflicts on main. We have conflicts on parse apparently.
Yeah, I can help. So I can help you solving them, but let's start by sharing the screen. Hello, Mageta.
Hello, welcome back.
Long time no see.
Long time no see. So let's go.
Uh,
So which things will stay? What do we have new on parse? Let's go in whatever order you want to go. It's fine for me.
on parse, we have. Actually, what was I doing? I
Namespaces.
have a, I have a div here.
What was I doing? We were introducing directives. That's what we were doing. And we
Oh
changed
yeah,
the
that's
part.
why. Yeah, that's why we renamed this to file.
Yeah, so just keep
Uh,
the master version and swap the program call to file call. Yeah, just keep yeah the one down there and change program to file. There you go.
uh,
What's next?
yeah, we keep that. The other one is main, and I'm pretty sure you can just keep whatever came from master.
Um. Oh yeah. Now we can man we can stop going to the main just to swap the example file. How good is that?
Okay, that means I need
Just
to.
nuke whatever is in between the head and the 45. All of this is gone.
Uh, yeah, let me just
It won't build
let.
because of the conflict, so be careful about that. We still have conflicts,
Uh,
right, in other files.
Not really. This was the last one.
No, so you should be able to do build in the terminal.
Parse command line and run. It's unbound.
Just do build. LSP should be
Okay,
working now.
there we go.
Cool.
Yeah.
With the minus example, I don't really care, so do whatever.
This is not part of the merge conflict. It's just that I had renamed something for some reason.
Yeah, if you keep the renamed version, you need to change the tests because they will fail. And CI will catch that.
Nah, I'll just keep it as it was.
Okay, so merge done. Great.
Commit.
So let's continue. Where were we?
Um, where were we? Actually, I need to do a small addendum before we proceed. Not here. Um, Actually, let's search for directive. Here.
Oh,
I
I
wrote
read
this
this already.
down.
Yeah, I
Yeah, I
read.
wrote this down on Saturday. It doesn't. I think it doesn't compile, but
It doesn't
oh no, it
compile?
did. Oh no, it did. We did do build, right?
Yeah, of course it compiles. Yeah, so you can have a directive that you literally like.
Oh right, I need more arguments now.
Oh yeah.
But yeah, basically the reason this is here is because I was doing I was thinking about modules on Saturday, and at some point I was like, and I was doing that while I was testing to do the debug session that we did, right?
Mhm.
And at some point I was like, I just instinctively did something like comment.
That's nice thing to think
Uh,
on a Saturday, by the way.
Well, we are genuine nerds. That's what we do on Saturdays.
was it
I'm not even
here?
joking. Most people don't even think about those. It's-
Yeah, it's not here. Yeah, at some point I was like, okay, let me just comment this, and I did comment, blah blah blah, closure style.
Ah.
And then I realized, oh, actually this won't work because this is not implemented, and that's why I just added that line
Could
there.
you could you put one example of that in the in I think modules.karuta for us to see if it works?
Here, right?
Yeah, put a comment directive. We have a comment directive now.
Because we always need more comment
More
types.
forms to do comments.
I was thinking, aren't these directives also a relation with the code and the compiler?
In some sense, they are,
Yeah,
yes.
I think abstractly yes.
Um, but yeah, we can do something like
Put some
this
yeah.
is not a fact because it's
By the way,
commented.
Mario, I think it's leaking some music from your side.
Uh, ah,
I can't listen.
okay. But yeah, we can do this, right? And then if we
Does this work?
do um, June, exec, Karuta,
Dash dash compile
compile,
and then the file path.
examples, modules.krt. Actually, let me put, oh, there's a debug already.
Yep.
This should just run the code, right? Actually, no.
Compiler pattern matching failed. Oh, it worked then. We already went to the preprocessor, which is the one that removes things, right? So we are
Compiler,
failing on the
yeah,
compile. Yeah, we are failing the same place that we were failing before.
right, because we have other directives that are not implemented yet, of course. That's why it's failing. In that case,
No, wait. In that case, comment everything aside from the comment directive
comment
and
everything
see if
aside
this works.
aside from the comment.
Yeah, comment everything aside from the comment. Yeah, so try to run this. Yep,
Okay,
it already works.
so if we do F, yeah, this is not a fact, is indeed not a fact. It's not in the functor table.
What is the /00 there?
That's the query, remember, its name is empty. We should probably redo this printing so it uses the nomenclature that we're going to use for modules, right? So it would be actually like, instead of this slash, it would be something like a single quoted atom with 0 here, right?
Wait, why is that the correct nomenclature?
Because remember, we desugared the
Ah,
query into a predicate with an empty name.
yes, yes, yes. That's
But
true.
yeah, this is not a fact. Is indeed not a fact. It's not compiled into memory.
Yep.
So
Okay,
yeah,
so we have a
yeah,
common directive. Convenient.
we have a we have a comment directive. So now if we want to comment a block of code, it's very easy to do.
Okay, okay. Let's go to the error now. So that's my
Halt.
first question. The first implementation, are we gonna save module stuff in memory or not, Marin? Because I feel that if the answer is no, we have an easier time.
It depends. The problem with trying to compile it to a file is, first of all, do we have serialization for memory data
No,
for the VM? We
but we can
don't,
make
right?
one.
Yeah,
I know how
now
to do
we
that.
will need. Sorry, Magetta?
I know how to do that very easily
Oh, you do?
with a library. Buttery.
Info library. Okay. Because here's the problem. If we just compile the modules to disk, um, first of all, are we going to? We have to answer some questions. Like, okay, we have a nested module. Should that be a separate file?
I think so, yeah.
Okay, but then that means that when you compile this, since we're going to compile it separately, we need some way to we need to include the symbol table for the module in its file format so we can refer to it later
Okay,
when we
okay. Let me
compile.
rephrase the question because I got my answer. If we go with like saving the module somewhere, we're gonna have a lot more work. So is it
Oh,
reasonable to just make it like interpreted for now? So like the modules are not the translation unit, but they work, and then we
I
add them
mean,
as translation units,
I mean, they can be a logical translation unit, and we can just have them hanging around in memory and not save them to disk. Actually, that's another option.
no, but I think that's not a good option because when we come to the point of making a binary form of the memory, I think it will. We're gonna have this conversation again of like, okay, what is it? What is the unit, the atomic unit that we're gonna save in the disk? I think it should be modules, just like OS does. I think so.
Uh, well, that's one option. Yes.
Yeah, but I
Um,
think I'm proposing for us to like separate those two concerns. Now we just try to make the module system work, and then later when we do to the when we have the conversation about making the binary form, then we reintroduce this question of and this solution of like, okay, are we going to serialize modules or not? I think they are married together, these two questions.
there's also the option of just dodging the question and doing what Zig does.
Which is,
And Zig actually prefers to have source modules, actually, and to link everything statically when you're doing the final executable.
but we're going to do the same. But that doesn't mean not doing the former, no?
Well, it means we don't have to worry about module compilation. We only have to worry about producing the final binary, which means
The
we
program,
don't
the
have to.
application program.
Yeah, the application program, which means we don't have to define an intermediary strategy for the modules themselves.
Is that a good idea though, in your opinion?
Uh,
Because I think that if you have a program that is using 50 modules and you can already precompile the modules in advance, that sounds like a good deal, no? Because in the strategy that you described, you need to recompile the 50 modules again to statically link with the application program after compilation.
um,
Like the only
that
advantage
is
of precompiling things is for to gain compilation time later, right? That's the only reason to do it.
well, unless you also want to distribute a precompiled library, right?
And there's
That's
also
also
like making like a closed source argument, right? Because I have a thing and I made a library, but I want you to pay me to use it. I can just
Oh,
give you a binary that is
but
that is
then
very hard to reverse engineer.
but then we can dispel that, and then we just put the license of everything, including a standard library, as GNU Afero. Solved.
Well, okay, Marinho. Your opinions.
Uh, let's leave this discussion for later
Awesome.
because
I like that answer.
right now, yeah, because right now I'm mostly concerned about the semantics of modules and not how we're going
Yeah, we already have
to.
enough work with just the semantics. Let's just go. So let's go to the pattern
Uh,
matching that is failing on the right there. Line 43.
yeah, it's this one because we have comments, but we don't have any other directive yet.
Okay, so which directive should we do first? I think signature is easier. Am I wrong?
No, it's actually easier because this is just changing the compiler state. It's not actually, well, I mean, the compiler stays outside of the memory that we write to, right?
I think
The
we need a
memory that
signature map in the compiler state now.
we need to make a map from
A name to something else.
yeah, from a name to either a module or a signature. Okay, first question: should modules and signature have the same live in the same namespace?
Magit?
I don't think there's an obligation for that because you can have a, let's say, okay, here's an idea. So if you have a library that should enforce a behavior so you can implement your own interface, you should be able to import only the interface and implement yourself the module, right?
Hmm.
That doesn't tell me if they should have the same names, live in the same namespace or not.
What
Well,
does tell you then?
does that does tell you that they don't need to, which is the counter of the question you asked.
Yeah, that's well. I agree with Mageta that it does. That answers the question that doesn't it need to? No, it doesn't need to.
Okay, they don't need to live in the same namespace, but they also don't need to live in separate namespaces.
Yeah, but I think the proper question is should they? I think that's the proper question. What are the disadvantages of making them separate, for example?
Uh, well, that's more bookkeeping in the compiler. That's the first immediate disadvantage.
I think for
Um,
organization purposes, it's better to have them separate.
but the problem, another disadvantage is that actually the same name can mean different things depending on where you use it.
Oh, but that's already true, no?
Is it?
Ah, I see the problem. If we make them in separate namespaces, you're going to be able to make the name of the module SIG-A as well.
Yeah.
That's bad. I dislike that. Mageta?
Comment it again. Sorry.
You see line 3 in there?
Yeah.
We're making a module called A and and it's using the signature with the name SIG-A. If we
Yeah.
make the two namespaces for modules and signature separate, we can make the module name SIG-A as well. And it would mean something different.
Uh,
Mageta, are you there?
Did I drop?
yeah, I'm thinking. I'm thinking.
Okay. Okay. I vote no for that. For that reason.
Congratulations, Lemos. You are on Scheme, on the Scheme camp.
I, I can't really judge the consequences of that. To be fair.
The consequences is that a name has different semantics now. It can potentially mean more than one thing at the same time. It depends on the
Yes, but
context.
yes, and maybe that is desirable.
Yeah, I think that's not desirable because I'm reading a label. This is the same reason I hate shadowing Magit. It's the same
That's
argument.
mm, that's a really hard thing to think about.
What is your vote, Mani?
I'm more inclined to keep them together, but that's just because I prefer to have a single namespace, if at all possible. I mean, we already kind of have separate namespaces for like predicate names and variables, but because they have different naming conventions, like a variable must be uppercase,
Yeah,
that's a bit,
capitalized.
yeah, that's a bit
Okay, so
less grave, but I'd rather not increase that, you know.
while Magetta thinks, let's just implement them as a single namespace. Okay, because I think Magetta will agree at the end.
There's also the question of, okay, should modules and predicates also live in the same namespace?
Um,
Wait, and wait. So modules and predicates exist in the same. Yeah, because they can collide as well, right?
yes.
Yeah, like should you be allowed to have a module A and also a predicate A?
Hmm.
Although actually that's not quite the same, right? Because predicate is segregated by its arity as well, and a module isn't.
And the
Yeah,
module
the module
will,
would
yeah.
just be
If it would collide with anything, it would only collide with a zero, basically.
mhm.
Yeah, but you're never gonna see a module being used in those terms, right? A module is always gonna be module name and then column.
Yes, that is true.
Yeah, I think it's less egregious to have them in the same name, to have separate namespaces for modules and predicates. But I don't know if that's gonna make it inconsistent because that's gonna like mislead the expectation. Because sometimes it is in the same namespace, such as the signatures and the modules, but some other times it's not, such as the modules and the predicates. Okay, I never thought of that actually. Yeah.
Welcome to the Lisp 1 versus Lisp 2 debate, Lemos.
What was their decision during that debate? Separate all
It
the
was
way,
never
or
it was
united
never
all the way?
settled. It was never settled, Lemos, because Common Lisp is a Lisp 2 and proud of it, and Scheme is a Lisp 1 and proud of it, and they never reconciled.
Okay, so Common Lisp
And they
has
fight
the
to
separate.
death.
Okay, so
Maybe
Common
not that
Lisp has
part,
separate
but
namespaces for everything, and the
Well,
scheme
Common
has
Lisp has
every
separate.
one a single one.
Well, technically, Common Lisp has separate namespaces for functions and non-functions. So yeah. Although that's kind of a lie because Scheme has separate namespaces for macros if you want to be pedantic.
So they were inconsistent. Even the scheme folks were inconsistent on that.
That's because you need to check if a symbol is bound as a macro when it appears in a call, right? And then if it isn't, it can still be bound to a value, which may be a function.
Okay, I'm more inclined to say signatures and modules should live in the same namespace, but modules and predicates can be separate. That's what I'm inclined right now.
Okay. Let's do it like that then. We're gonna have then.
Yeah, we need to put something in the compiler type up there, line 24.
Compiler here. Okay, so we
Yeah,
have
we
an
need to
entry
put
point.
something in here.
We have the p register, and we have a functor table, which is for predicates. And then
Modules and
we need
signatures map.
yeah, we need like a module table or something.
No, we're gonna make them together, right? So it's modules and signatures.
Um,
We can call it sigmod table.
Igmod.
Sigmod table.
That's absolutely horrible.
Come on, man. We need some
let's call
lore
it
in our
this.
compiler.
Let's call it the sigma table. Why not?
Sure.
Sigma tables.
Okay, so it's a variable. It's a name, right? It's a tag,
Yeah, we
a
need
functor name. It's up
to.
there actually. We made a type for it.
Yeah, we need to. Functor name, functor map.
Oh, but the functor name has the arity. We don't need the arity, so it can just be a string in that case.
But what is the value type is the question. Um,
Well, in the case of signatures, well, actually, it's easier to say the modules. In the case of modules, is a bunch of clauses, which may include other directives.
okay.
No, actually, it's a pair, right? It's a pair of the module signature and the list of clauses.
Uh, okay, let's make type sigma map equals.
Yeah, we need to create a module, as we did in line
Uh,
4.
na 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 na. Batman.
I think we need to
At
tag the union, man, for the.
we do. Yeah, no, we do. Struct type t equals um,
So this is a string, for sure. This is a string.
module of um, hmm,
Wait, I'm confused. Can you go back? Is this the value or the key? I always get confused.
this is the value.
This is the value. Oh, so this is okay. So module of, and then it should be a pair of the signature name. Well, not the signature name because we also want to allow to have inline signatures.
Okay, so for the sake of expediency, let's say that the signature is just a functor from the AST. Actually, let's put this in the. Should we put it together with the AST?
I think we should. We're gonna get confused pretty fast. Or you make a separate module called modules.ml.
That's kind of meta.
That's
And then
kind
the
of meta.
module of that file would be modules.
Because I think it's going to be confusing because these ones, the AST here is only related to parsing. Everything here relates to parsing at some degree, to some degree. I think we should try to keep it that way because, for example, we don't parse the module AST, we parse the directive AST. So we need to keep that difference in mind.
Okay. In
Well,
that
but no, no,
case,
no. But we'll go back. I think, but that makes it convenient, right? Because we have the clause on line 6, and if we make it a signature in a module clauses, then it makes our life easier in there, right?
hmm.
It makes it easier because this will be a recursive type, right? The signature the module has a bunch of clauses as well, so why not?
Yeah. I think this representation may cause problems with nested modules potentially.
Mm. And it's gonna get confusing because, well, not necessarily, because we also have the comment directive. A directive is not a module necessarily, or a signature for that matter. So I think it's fine. But it's up to you. What do you prefer?
Man, we'll have to implement scoping essentially.
Scoping in which sense?
Well, we need to be able to say that this cons
Is
is
not the
not the
same
same
cons
as
as the
this
cons up there.
cons.
Yeah, that's one of the reasons that we implemented cons twice. To verify if you can make that happen.
Hmm.
That was already in my checklist. Scoping them.
We need some way to identify a module which is not its name and is also. Would it be too crazy to use lists of declarations as map keys?
Wait, why can't we use the modules as its name as the identifier?
Because the same module may have a different name in different places.
Wait, the same module may have the same name in
It
different
can have an
places?
alias, right?
Oh, we're gonna implement alias now as well? Okay. Uh, sure. What's the problem?
That means we can't just use the module name to refer to the module in the compiler, because the name may be different depending on the context.
That's true. That's true. What else can we use then instead of the name?
Well, the only thing we have is the module body, basically.
Wait, but how would you do that? How would you identify? Would you wait? Are you thinking? Okay, that's what was your question. Using a list of declarations as a key in a map.
Yeah, because then we don't really necessarily have to worry about um, about what the module is called in other places, right? Because you can just say, okay, we're in a context where we have A refers to
Yeah,
this,
but that
right?
that sounds expensive
Why? We have immutable data structures.
because a key may be a gigantic module body.
And what's the problem?
Well, that's my like if you have a module that is gigantic in the body, like it has like 500 definitions because it's the lists module, for example. We're gonna use that as a key. Don't we have performance issues by using that at all?
Well, how fast is the hashing algorithm used by the batmap is the question you should be asking.
Ah, so fuck it. I trust the guys for the library then. then I don't care.
Okay, so a module is AST deco list.
No, but we are
Or
missing. No, we're still missing stuff. We need to save the signature of this guy, which can either
we
be
need to,
inlined or a name. I think if it's a name, we need to do a lookup to find the signature properly, and then use the signature here.
I have a question actually. Magetta, does it make sense to ascribe multiple signatures to the same module in different contexts?
Let me think.
Okay.
So you want to have like a so ascription, you mean like for example you're doing opaque ascription, like with a type on a module. Is that what you mean?
Yeah, like say you have just a module body, okay?
Hmm. Yeah.
And the module body is sufficient to implement like two different signatures that you have lying around.
Yeah.
Can you say, okay, in this one place, I'm going to use signature A with that module,
Yeah.
and only the bindings from the signature A should be visible because that's the signature we're using.
Mhm.
Hmm. Yeah.
And
Yeah.
then in the other place, we use the signature B, and then only the bindings for signature B would be visible, right?
Yes, you can.
Yeah.
That's what SML calls that opaque ascription.
That means actually that we shouldn't actually store the signature together with the module at this level, Lemus.
No, but we are basically instantiating the module at this point. We already compiled. We're creating it out of scratch. This particular module has a particular signature. No?
No, it may satisfy multiple signatures.
No. But that's a different thing. If it's a different signature, when we go to the compilation phase, we're gonna find a different naming there. But I'm talking about, okay, we are
But it's the
instantiating this
but
module
it's
that
the
is written in the source code right now.
yeah, but it's the same source code. It's the same module definition in both places. It's just they have different signatures.
Wait a moment. So you can have, but aren't we gonna have a conflict of the names? Like module A with signature A and module A with signature B? Or is that allowed in SML? Can you do that?
They would have well, no, they would have to have oh yes, they would have to have different bindings at that point, right?
Yes.
Okay, but I'm
Let's
still
see that way.
confused. If you're not gonna save the signature at this level, which level are we gonna do that?
Hmm. Well, if the Sigma map is a map from name to whatever, if it's a module from name to whatever,
Man, it needs to be here in my opinion. I can't see other place.
uh, we should also have the option of saying, okay, this is a module and I'm not giving you a signature, so it should just have everything, right? As well.
Wait, is that an option? I didn't know that. Okay.
What do you mean? We have modules without signatures everywhere in this project,
No, but
Lemos.
I thought the modules would be have implicit signatures anyway. Well, but in the
They would
case
have.
you're right, right? If they are implicit, they're not written. Hence, you are exporting everything. So it should be optional then. It should be like option signature, option signature.
Okay, let's make a record here actually. So signature. We have
We have to make
to.
another type for the signature. You just figured that
Actually,
out.
actually no, we don't because we can just say a signature is
A functor. A func. An
a
AST.func.
func, an AST.func. Yeah.
Um, that's annoying because we're gonna have to have we have the there are gonna be a lot of corner cases that make sense for functor that don't make sense for us. So I rather destructure the functor to something a little bit more constrained, but that's okay.
Okay. What corner cases?
A signature can is a functor of mandatorily arity true, right? And the second member of, and the second argument of that functor is also a functor of arity true. Well, sorry, not a functor of arity true, but a functor with no name.
All right, because a signature is going to be a list.
Exactly. But you see, there are already constraints that don't apply to func, but apply to signature. That's why I wanted to create a separate type for it.
Actually, there's a question. Um, should we dereference the signature when you construct the module?
I think so,
Okay.
but that may be a
Dereference.
controversial opinion. So let's ask Mageta. Mageta, would you?
Dereference. What do you mean by dereference?
I
Like,
can
should
explain.
we?
No, I can explain what he means. He means like, do you need to do for declaration for the signature to use it, or can you just say
That
sig a here and then
Huh?
down there you can put the signature?
no, 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 no. That's not it, Lemos. The question is, if we do module A sig A, should we store this as
Yeah.
sig A or should we store this as the definition of sig A?
Oh, I see. Um. Does that matter? Really?
It matters because of my question, because of the for declaration question. If we save
Oh, I
the
see.
No.
name, we can later do the deref, only
S-
later, when we need it, for example. If we do it the
Ah,
way that Marinho wants to deref immediately, we need to already have it. That's why it matters.
Right, we would have to add another pass to the compiler to collect all the signatures. Yeah, that sounds kind of messy actually.
Yeah, so that's why I asked the reference question, the for declaration question. Okay, Mageta, what would you? Well, it's harder to make it.
I think it's hard for me to make any judgment on that because from the I mean it changes the behavior in which you can assign apparently,
Uh
right?
huh.
Yeah, because like if we say, okay, I'm going to use the definition of CGA here,
Hmm.
but if this definition appears down here,
Yeah.
then we have a problem if we
Hmm.
insist on using the definition of the signature.
Yeah, a problem per se because we know how to fix it. It's just annoying.
Yeah, in order to fix this, we would have to add another pass to the compiler, collecting
Yeah,
all the signatures in each module.
yeah. I think we should go with the simpler one first. So let's immediately dereference, Maria. I don't think this is a good excuse to do another pass in the compiler.
Kill me, I just realized something.
Go for it. Yeah, no, this is hard, folks. I have no idea why.
No,
Like,
no, we actually are being forced to implement full-blown lexical scoping lemmos because what happens if we use CA here?
well, in this case, well, put the CA on the top, please. We're gonna be using the CA from outside of the module. Yeah, that's what it is. That's that.
Yeah, but that means that this module must know what the surrounding scope has as well.
Ah, sure. That's also true. Yeah, that is lexicoscoping, isn't it?
Yeah. Okay, so we have a signature, we have a body, and we
Wait, are
must
we gonna keep the
also.
signature as a func, even though I just explained that this is a special functor? Or
Well, an atom is also a functor.
no, sure, but okay. So we're gonna be doing all of these checks every time that this functor mandatorily has arity true, mandatorily has the second member has no name.
No, it can have arity 0, no, if it's a name, if it's just an atom.
Oh, if it's inlined, right? Like line
No, no,
15.
if you're referring to it by name, actually.
What? No, I don't understand. The only way to not have a name in here if it is if you have inlined, right? Like line 15.
Oh no, you're talking about the label of the functor. I'm
Yeah.
talking about the arity of the functor.
Ah. Okay, my bad. Yeah, no, I agree with you then.
Uh, well,
Okay, we can keep it as a func to not spawn another type. But you're gonna have to do these checks all the time, which is kind of annoying.
we need to. Yeah, here's the problem. We need to. In order to do proper lexical scoping, we need to bind the module to the environment it's being defined in. But
Sure.
in order for forward uh, references to work without having to do for declarations necessarily, we need to construct the entire environment before constructing each module, but we can't do that without constructing the modules. We need we may need laziness here. We may
Sure.
need laziness.
Let's not try to be like to optimize it like right now. Just make it as we go, and then we can keep changing as we go.
It's not a matter of optimization though.
No, it sounds like one. It sounds like we're doing otimização precoce here. We're trying to figure out the
No, it's
future too much in the future.
no, it's not optimization because this is about I need to refer to a thing that does not exist yet.
I'm not saying it is optimization. I'm saying it feels like otimização precoce. Like we're trying to be too ahead, and then that's causing headaches. Let's just go with like as of what makes sense right now, and we can refactor it later. So this is a
The
list
other
of
alternative,
declarations.
is to use a mutable map, but that sounds kind of gross.
Yeah, no, we're probably not gonna do that. But let's wait for the need of it, and then we can change it.
Yeah, this is a list of declarations.
And the other case is well, we didn't make a special type for the signature. So do we need a signature? I think we do. Or do we?
Um, and then we
Oh,
need
we
to
do. No,
say
we do. We do. We do.
signature of ast.func. And this one actually, well, it needs to also be possibly an atom if we want to allow aliases of signatures. So yeah,
Wait, when you say an atom, do you mean? But a func is an atom, right?
it can be.
Yeah, you can. Okay, that's fine. Okay, I think this is a good type. We have a module which has the signature and its body, and we have the. Okay, let's finish the sigmap. No, you need the sigmap there.
Sigma map is
The string
string
sigmap.t.
sigma map.c.
There we go.
Why? Oh, it's because of this. This is a sigma map.
There we go. Awesome. Okay, so oh, the initialize function. We need to put more stuff to initialize together now.
Sigma map dot empty.
Yep. Okay, this
Sigma
is still
map
should still
dot
compile,
empty.
right? So that's nice. Okay, so now let's start extracting information out of the. What is it complaining about there?
It's because this has another field now.
Yeah, that makes sense. We need to start doing pattern matchings on the directive now. So let's copy the comment directive pattern matching and let's swap for module. And let's go from there. Let's do signature first though. Signature is easier.
Signature.
We need to check we need a guard here. We need an arity. We need to check the arity to make sure it's a true arity.
Arity. When arity equals 2.
Yeah. And now we need to check
And we also need actually
the
the
elements.
elements equals name and body.
Are you sure that those are their names?
Wow,
That's not
this is a
correct.
list.
No,
This is
it's
a
not
list,
semicolon.
Lemons.
It's double column.
No, because this is a list. This is a full list. There's no. This is not a tail, Lemons.
Wait, this is a full list. I don't understand that. What does that even mean?
Like, this is a list. This is
Yeah?
the first element. This is the second element, and the tail is new. Oh,
Ah,
I guess it's not called new in OCaml, right? But you
no,
get
but
what I
I
mean.
didn't know you could do that with semicolon. Okay, that's cool.
I mean, this is how you construct a list. It should be the same syntax for the pattern, no?
No, I don't know. Okay. Um, we need to check that the name. Well, we need to save the name somewhere now. Yeah, we need a body. Put parentheses in this branch here. We need to do a bunch of lets now.
Actually, no, we don't.
We do.
We need to say compiler with, and this actually needs to be curly braces. Compiler with, except we do need actually the sigma table here, right?
Mm-hmm. Mm-hmm. Sigma table equals. You need to do
Sigma tables,
an open
sigma
of the sigma table
table.
module to have the add function. You can either do it, yeah, you can either do it in here, yes.
Add name body.
That didn't work.
This is not the order, I think.
Oh, key,
Takes the
value, and then
key
the map.
first,
Okay,
then
so
the
the map
value.
comes at the end.
So this is last.
It's still fucked, which is interesting.
Uh, this has type blah blah blah, but it was expected to be. Oh, this
Can you
is
go,
because first is the key. Oh, right, because the name actually needs to be destructured as well. This needs to be ast dot
funk?
functor namef. Then we need the
Elements.
arity needs to be 0. Elements is empty list.
Well, but in that case,
And
let's also do the same trick. Let's remove the guard. Put arity equals true on line 65 as well. I think
on
that's
line
also good.
65.
Yeah, put equals to true here, and then you can remove the arity, the guard down there. Yeah. Okay, so you have a name f. What is the current problem? The
Let's
problem probably changed.
do. Pa, 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 pa.
I think it's because we did the things in reverse. I think up all the way up there, the key and the value types, they are not that.
No, but the t
In
that
the
you put
functor
up
map, in the functor
here
map,
is.
yeah, the int is the value here.
Oh, that's backwards.
So yeah, so it was. That's why I asked. I was so confused.
Well, in that case, this is just a string map then, and this needs to be, well, first of all, this doesn't need to be ordered, but this needs to be,
Good luck.
uh,
Good luck on that one. That's hard.
comp time entity. Why not?
Sure. And this t is equal to string.
Oops.
Yeah.
Uh, type t equals string and does not include blah blah blah.
Yeah, I need to derive the ordering probably. And then on line 19, it should be comp time entity. Okay, what do we have down there now? Still fucked,
Uh,
which is bad.
this needs to be sigma signature actually.
Okay, but it's still fucked. It's an expression, the body. Makes sense. We need to destructure it all the way on line 68. So this is
That
what? This is a
means
functor with nameF equals to empty.
no actually.
Wait, what? What do you mean?
This is a functor. There we go.
Okay, so we're gonna allow names in the second member of the signature. Why? That's weird.
Because what if we want to make an alias?
But we haven't even talked about the syntax for that. How's that gonna look like?
What do you mean? You just do
You just do?
sig alias is defined to be sig a, no?
Oh, so that's the syntax for it. Okay.
What else would it be?
I have no idea. Like, I don't. That question doesn't make sense. What else would it be? I don't know. We can put anything. We are creators of the language. Sure, sure, that works for me.
I mean, I guess if we want to be pedantic, we should check if this is either an atom or if it's a proper list, right?
Yeah, I agree on that. Yeah, but that should have a yeah. Put a to do there.
To do
Put a
check
guard. Put a guard to
if
check the alias
this
case.
is an atom or a proper list.
Yeah. Okay, so then we call compile and we just added to the sigma table the signature, this signature in particular, and everything is rosy. So is that it for signatures? Do we need anything else for signatures?
I don't think so.
I have a question. In the
Okay.
case of the modules case, because of the lexicoscoping, don't we need to add an environment to it? To the type, to the record? Or am I daydreaming?
We kinda do actually.
Yeah, so we should go to the module record and add a context key in there. Or whatever you want to
Uh,
call it.
hmm. Hmm. I almost think we should actually add a second pass, another pass to the compiler, to be honest.
Why?
Because that also solves the problem of the recursion, well, not recursion, the laziness issue I was talking about. Because this signature, right?
Mm-hmm.
Actually, even if it was down here, it should be in scope for everything in the body of this module, right?
Yeah. It should.
Uh, but in order to know that, even if the signature is after the module, we need to collect all the signatures first, no?
Oh, it depends. If we're gonna do the lazy way, we just don't allow that. You can't use signature of C, for example, if it was separately declared, because it's not in the scope of the module A. So you can only use sig A inside module A. That's
Okay,
the
so
lazy
the
way to
order
go
of
about it.
okay,
The order matters.
so the order will start to matter if we do that.
Yeah, but that's very consistent, right? Prolog is a language that the order already matters.
Actually, it only matters if you are declaring the same predicate with the same arity multiple times.
Yeah, but it matters. So it matters. If we make the order doesn't matter, that would be nice from a programmer's perspective.
But the order doesn't matter if you're defining predicates with different names or different arities.
If you grab a program that does a particular output and you swap the order of the predicates for the pattern matching, it may potentially change the output, correct?
Yes,
So in my
only if you're
mind, the order
changing.
always matters. Always. I'm always thinking about it. Even though it's only in regards to the same predicate with the same arity, because it has such a gigantic side effect, I always care. I always care about the arity in this language.
Okay,
Um,
so let's do it the lazy way then. Let's say that the order matters.
no, but that's the thing. We don't have to apply the same principle for the directives if you don't want to. Although, I think, what was it? Was it Magetta with F sharp that explained to me that sometimes, because the order matters, you can like redefine something? Essentially scoping, but on the level of declaring functions, right? You can use the same name as
Uh,
before because you are overriding the previous declaration because the order matters, or
yeah,
something
that's
like that.
basic. Yeah, that's basically the distinction between let and let star, right?
Yeah, exactly. So
Uh,
if you want to exploit the same trick, we could make the order matters on purpose, not only because you're lazy. But I don't know if that's worth
honestly,
it exactly. So,
honestly, I'd rather not.
not what side? Which side?
Not allow rebinding the name of a module or signature
I see.
because
Well,
that can get
in that case, we
confusing
need to
very.
change the code. We need to do a lookup before doing the addition and throw an error.
That is true. That is actually true. That means.
Instead of directly calling compile, we need to do an if before, which is going to be probably find opt, right? So match, no, not if, match find opt,
Find opt
and I don't remember the order of the arguments anymore. So good luck.
name f
Sigma
sigma
table,
table.
and
Yeah,
if
it's the key,
first
then the map
with,
Ah,
with
and if we have a sum, we need to throw an error.
fail with uh, comp
Signature.
time name collision.
I wouldn't make a better error message. I would say signature already defined. Already defined.
error message. Comp time, name collision, blah blah. I would be scared of reading
Yeah,
that.
I would be scared.
Uh, name f already
Signature.
defined.
Yeah, but we can say more details. Say that the signature already defined. We have the name F.
Um,
It's easy.
but it may be a module, not a signature.
Oh, okay. So we are making. Okay, that's fine. But that's just bad error message. Like we could do better. But okay. You need to put a net at before the after the fail with. That's the problem.
Name, let's say name collision when defining name f.
When defining signature name F, because that much we know. You're trying to define a signature. Okay, that's better. Okay, and then if you have a none, Then we do whatever we were doing before. Something got fucked pretty hard. Can you scroll up? I think it's parentheses
Super.
problem. Go on, Magita.
No, nothing.
Go above.
Already.
Go above. What is... How did we fuck up? I'm confused. Oh, I know. I know. Go back, go back, go back, go back, go back, go back, go back. It indented the
Oh,
multi-declarations and everything else. We need parentheses. Well, we need to close a parenthesis in line 87.
87.
Yeah,
Oh,
close
right.
another parenthesis in there. Okay, now that's correct. Okay. Um. Okay,
Yeah,
back to the original question.
except this is still wrong indentation-wise, I think. Because this should be here, no?
Yeah, that should be here, but the formatting is putting it nested, right?
Actually, the formatter is fading. Line
125.
125. Oh, because there's this. Okay. There we go.
Okay. Is it correct now?
It is.
It is. Okay, now let's go back to the original question. Do we need to put a context in the module record because of the lexical scoping? And then you suggested that we rather do... And then we went to the discussion if you're going to allow you to define a signature below the definition of a module.
Can we do mutually recursive types?
Yes. In
Yes,
OCaml,
you can.
yes.
Okay. Environment is a sigma map. And this needs to be type.
Oh, okay. I don't know if that works. Does that work, Mageta?
Yes, you can.
Really?
There's no problem with that.
Does that
Yep.
compile?
You don't need the rec though. But
There we go.
Okay,
yeah.
that compiles. Damn. Okay. Okay. So let's go. Let's continue. So now let's implement the module one, which is going to take a lot more time because it has different use cases.
Mm,
I'm almost suggesting for us to make the signature in the module checks in a separate like directive.ml because it's going to be huge. But okay. Let's just put it in everything in here and later we can separate to make it better organized. Doesn't matter. Okay, so let's make another pattern matching on the directive.
okay. If it's a directive.
And then we need to check if the namef is module.
Oops. Fail if to do. Right, so we need to check if namef equals module.
So the arity may change. So we're not going to check for the arity now because it may be 2 or 3. We can do a guard to check if it's at least 2. So that's better, in my opinion. Now we need to check the elements, right? We need to check the elements. We need to check that the first
We
one
also need
is an
to do
atom.
this. Yeah, we need to check if arity equals.
No. Let's not check the arity now because the arity can be 2 values. So let's just do a guard and check the arity inside the pattern, the body of the pattern match.
Okay.
So now let's
Arity.
check the elements. So the first element needs to be an atom, so a functor with arity 0, because that's the name of the module.
Namef.
Yeah, making this
Arity
thing
0.
homoniconic is really convenient because of this reason. We can literally use the same data structures as we have been using before. That's very cool. Very cool. So,
but then we need to be able to decide.
yeah, now we need to extract the body and do it internally. Like, we need to grab everything else from the tail, and we need to check if the arity is 2 and then check the body accordingly, or if the arity is 3 and then check the signature accordingly. So just bind the tail and do a guard to see if the arity is at least true, and then we proceed in the body of the pattern match. Did I drop?
Nope.
I'm thinking for a second. What if? Okay, we say module, we give it a name, then we need to we give it a signature. Right, let's just say ast.func, but the signature is optional, right?
Yeah, that's why I said just bind the tail here, and you need to do the inspection inside the pattern match. We can't do it in here.
Uh, Let me say
Module tail.
module tail.
We should put a guard on this in this pattern match though to check if the arity is uh, at least one, at least. Well, we could be more specific. We could check if it's true, one or two, because if it's none, if it's not, if it's 0 or 3 and above, this is an error. We should not have it, right?
Yeah, rt equals 1,
Pipe, double pipe.
or
I think it's double pipe, no? That's Zig, not OCaml.
unbound value or.
Yeah, it should be double pipe.
Rt
Equals 2.
equals 2.
There we go. That's it. So now we need to make the body of this. Okay, the first thing, yeah, this is gonna be wild. This block is gonna be huge. The first thing is you need to do a lookup. So just copy, yeah. We need to do the same lookup as we did before. So we need to do the open as well.
Let open sigma map in.
Nice. Then name collision when defining module. Yes. And then if we have the none, which you didn't copy paste, I think, then we can do more checks on it. So the first thing is that we need to do an if to check if the arity is 1, and then if the arity is 1, that means
Yeah, we should probably make the signature here. Where is it? Yeah, the signature here should actually be option, right?
no. That's not how you do
Not
option.
option. Yeah,
It's
that's backwards.
yeah, but why does it need to be optional? Because I think we agree that we're gonna dereference.
That we're gonna dereference. No, it's
Ah, but
actually big.
if it's none, that means we need to create a signature for it, which is gonna be exporting everything.
Yeah.
Okay.
Yeah.
Okay, that makes sense.
We could just leave it as a none, with the understanding that okay, this means everything basically.
Sure, sure. That for now that's fine. Okay, so if the arity is 1, okay, my suggestion is, yeah, let's treat the case 1 first. So if arity equals 1, we can already, we need to compile
Actually,
the
if we
body.
just say this, no?
That works as well. That works as well. Let's check if the arity is equal to 1. And then let's treat that case, and then let's do the else later. What do you think?
Match arity with 1.
True?
Actually, no, we're gonna do basically the same thing in both cases, no?
No, because, well, we will, but we need to have an if somewhere when calling the compiler recursively, because we need to say that the module signature is going to be none in one case, and in the other case is going to be some. You see?
Yes, but we can move the match to be inside of
Yes,
the.
yes, we can.
Yeah, so let's do
So let's
this.
just do the body first then. No, we need to do the signature first because if am I saying bullshit? Does
Compiler
it matter?
with sigma table equals
Add.
add nameF um, something
We
to
need to
the
make a
sigma
let for
table.
it. Yeah, we're gonna make a let for this value.
Um, we're gonna make a let. We could,
So it's gonna be
we
let
could.
module equals module with capital M.
That could get confusing real quick.
Well, we do that all the time with references, for example. Let reference equals reference. We do that all the time. Um,
Yeah, this is going to be a module.
Open close
Um,
strings. And then we need the if, because if the arity is 1, then the signature is none. We can use the if expressions here, is better.
if arity equals 1,
Then none,
then none,
else.
else
Yeah, then we
some.
have to do a lookup. That's why we need to make it. We need to do this lookup inlined right here, which sucks.
Can't you just do head of the module tail?
Uh, Head of module tail. No, no. I'll be back.
Yeah, actually no, because we need to grab the. Oh, this is kind of silly.
I'm
Let
back.
signature equals in.
Yeah. Yeah, you
Let's
notice that
pull
you can
this.
just pick the head, right?
Yeah, let's put this thing here for now. Let's just say signature, then then we put the environment equals sigma table, and we say, if I can type, and we say
We need the body, right, for the module.
body clause list, but decal list. Oh, right, the type is wrong.
Yeah, we should put a list of clauses in the type of the module, in the module record up there.
And
Because
no,
we
this
may
should
have other directives inside the module, so we can't
yeah,
do
no, this should be a list of sigma map comp time entity. This needs to be decal
it should be a clause in here.
clause.
Yep.
There we go.
Ooh, that brings up a problem. We
Hmm.
need to forbid queries.
No, we can just ignore them.
That's kind of. I think we should report them. That doesn't make sense to have a query in a module, but okay. How do you grab the head
Ooh.
of a list, right? That's your question right now.
Yeah, this is unbound. Yeah, no, we need to do.
We should not do that though, because this may be new if you're doing implicit signature. Ah, no,
Implicit
but we checked
signature.
via the arity. That's why you're doing the unsafe thing. Okay, that
Yeah.
actually makes sense.
Is this head?
Yeah, let me check. List.head probably. Yeah. Okay, so something is broken. Well, we need to put signature. What is the problem?
Yeah, we need to unwrap it, and it needs to be a functor.
We need to unwrap it. Ah, okay, that sucks.
It's looking interesting, at least not.
What did you say, Maget?
it's looking interesting,
Ah, okay.
like watching Maria implement this.
Yeah, thank you, thank you. We try our best.
Each-
Yeah, we need to pattern match the tail, Marinho. That's the problem. Man, I don't think there's
Mm,
a convenient way to do that. Because the module tail can be any expressions, the way that it's currently written, but it needs to be a functor, so we need to pattern match on it.
hmm. Yeah, this is.
Oh wait, the module tail only matters if for the signature, right? No.
Yeah, what if we do a better check on this when here? When arity
We can
equals
do even
1,
worse. We can do the destructuring on the module tail, right?
we can, but then we'll have to do the module clause twice.
Ah, that's true, right? Because that may be new. Yeah, no, just go for it. Just go for the guard.
Yeah, let's put the parentheses here and let the formatter remove them if it turns out to be unnecessary.
And then
Arity
arity
equals
true,
2.
and then the functor, and then extract the thing. But here's the thing: can we do that? Can you extract information in the pattern matching of the guard?
We don't have to. We can just say module tail is different from the empty list and um, we need a predicate to check if an AST node is a functor.
Uh, uh, we don't have. Oh, put that inside the clause module. No, 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 no. In the expression module. Yeah, expression module.
Let is functor.
No, 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 no. But this is in the wrong place. This is in the clause. A functor is not a clause; it's an expression. Do it down there,
Oh,
line
right, an
37.
expression 37.
So let,
Let is functor takes a t, returns a freaking boolean.
of course. Uh huh. Great stuff. Now,
AST dot expr
yeah, but this is
is
looking nasty.
functor
Like look at the pattern matching and look at the guard.
list head
And then
of
yeah, and
the
there is even
module
the head
tail.
on. Yeah, it's not head, it's HD.
And we need to recompile this, don't we?
Yeah, but this is gonna fail. But yes, we do need to recompile. Yeah, I think the pattern matching got fucked again because of lack of parentheses. No, not this pattern matching. I mean, the one. Scroll down. You see what happened there?
Yeah,
That's the problem. We need to fix that again.
there we go.
Is it compiling? Well, it is, but the
Almost.
type is still wrong. Oh, I know why. It's because we need to extract the functor out of the expression of the head in here. Ooh. It's getting worse. Okay. No, don't trust
This
LSP, man. Just compile the program. Don't trust it.
it is functor, right?
Uh-huh. Run Dune build. Let's go. Okay, so it is a real problem. The constructor AST functor belongs to the variant type expression.
Oh, right. We're
The sum?
missing actually the, yeah.
What? Ah, you need to put the sum after you do the extraction.
Hmm.
Ah, that's kind of bad, but okay. No, you need to remove the sum from here, man. Or you do another let in here.
Man, we can't just grab the. We can't. We can't just destruct this here like inline,
You
can
can
we?
make a function. Go to the expression module and like
But you want to
extract.
destruct, or
Go
destruct
ahead.
what exactly? The list?
Yeah, we have an expression. See line 3. Line 3, we have an expression, but we know ahead of time, because of the guard,
Mhm.
that the expression contains a functor. So what Marinho wants is to like
Oh, I see.
grab the head and then immediately extract the func out of it. I think we should
I
make a
mean,
function in the expression module to
I
extract
yeah,
it.
do in fact want to extract the funk out of Rio de Janeiro. That would be great actually.
What a bad joke.
thank you,
Okay, go
Maria.
Mageta.
You can, but probably the type will complain, right? Uh, I don't know if it's a different type though for the thing inside of it.
It won't complain, but it will make a warning of the non-exhaustive pattern matching.
Well, if it does that, you can always just put a suppress on
Oh,
that
of course.
expression.
Yeah, but no, yeah, Marinho is gonna do it in line. Man, it's better to do it in the expression module. But okay.
Let him have fun, Lemos.
It's becoming nastier as we go. But okay.
um,
Marinho is making art.
Okay, this should compile now.
and it does.
Okay. So, um,
We still need to handle the module bodies though.
yeah. Yeah, we have to handle a bunch of things, actually. So handle the
Uh,
module bodies. What do you mean by... Oh, you need to
we need to comp
recursively call this function.
yeah, we need to compile the body, but we can't just compile the body because if we do that naively, we're going to give things the wrong names.
Can't we just fold over the body and keep passing the environment forward?
That doesn't quite work because that will still clobber the wrong names. You see, if we have a cons inside of the module,
Mm-hmm.
we need to add a prefix to the name of the cons when we're referring to it from outside of the module. But in the module body, that prefix won't be there. You see?
Yes.
So we need to handle that actually.
Well, but that sounds like two different things. The first one sounds like something we have to deal with in the multi-declaration case. Because remember, we are already parsing the names of the predicates with the column, with the prefix. So we need to do the look aheads inside the multi-declaration, in my opinion. And what
No,
I
no, no, no,
said,
no. That's not it, Lemos. We're using the prefix when are we using it actually?
in the main.karuta.
Right, we have the prefix here, but that's not what I mean. The problem is if we are compiling this body and we're fighting these cons here, right?
Mm-hmm.
We need to remember the fact that we're inside of this module and add the prefix to the name. Otherwise, this is going to collide with other conses that may be outside of this module.
Okay, we need to go to the state of the compiler and put it in make it a way to inform the compiler that we are compiling a module. Like we need to give the compiler the notion that you are inside something.
Mm,
Can't just be well, I would say an option, but just to trigger Maria, I'm gonna say a boolean.
no, this needs to be a list actually,
Why?
because modules can be nested.
Oh, so it's a
So we need a
stack then.
yeah, it's a stack.
Awesome.
It's actually a stack.
Okay, your favorite data structure. Okay.
Decks are better actually.
That's such a weird thing to say.
No, decks are better than stacks.
What's your favorite data structure? You see, I like stacks.
Yeah, Marinho loves
Um,
stacks, man. Yeah, we need a stack. Yeah, we're implementing lexicoscoping at this point.
Module prefix, and it's initially empty.
Oh, we're gonna use a list for the stacks. Cool.
Why not? It has exactly the operations you need.
Yeah, I thought you would suggest to use a stack that batteries probably provide.
Uh, let's say this is a string list.
Yeah, they do have stack in batteries. Just noticed here.
It's probably implemented as a list under the hood, I'm guessing.
It's probably implemented as a finger tree if it's a list.
Why? It's a stack, it's not a deck.
Yeah, but why would you use a list if you have batteries or other data structures which are more efficient?
Because the extra efficiency is in operations that never happen with a stack.
That's a good argument. Okay,
And
so
they are more complicated to implement
okay,
than
so
just a simple
in the
list.
modules there, we need to do a thing. We need to append the name of the module that we just joined.
We do. We actually do.
Oh, not append, the cons, né? Cons.
Name f module, blah blah blah. Compiler with sigma table, yeah, and module prefix equals name f cons. We actually need the module prefix from before.
Yeah, I'm definitely putting this directive pattern matchings in a separate module. Okay, but now this introduces a new problem. That now when we are pattern matching the queries in the multi declaration, we need to immediately check if we are in a module. Because if we
We
are
need
in the multi declaration, we need to add the prefix, and if we are in a query, we need to ignore the queries.
in a multi-declaration.
Yeah, which are the pattern matchings below the directives.
Hmm, in a multi-declaration.
Yeah, so we need to immediately check if we are in a module right now.
Actually, no, we don't.
I think we do. Could you elaborate on why not?
We just need actually to. Let's see. No, we actually need to check the module prefix every time we add an entry to the functor table, and every time we try to compile a call or an execute.
Ugh. Okay,
And we
that's
need to check if the thing that we're calling is qualified or not.
what do you mean by qualified or not?
Like if it has a module prefix already in it, right?
Why do you need to
Actually, does
check
that
that?
matter? Well, if it's a definition, that can never happen because the preprocessor is gonna blow up. We made sure of that. If it's a call, if it's a call, we wedge the module prefix regardless, actually.
Yeah.
Unless we're referring to something from the outer scope, is the thing.
Yeah, the only thing that sucks is that this changes the code generation. That sucks.
Mm, hmm.
Well, actually, to make our lives easier, we should put. Yeah, that actually is way easier than I thought. We should put as an argument to the initialize function of the code generator an optional module name. Because then we can do the processing of adding the prefix inside the code generator. You see?
An
And if
optional
it's
module name. Okay,
yeah,
which
if
name
it's
should that
none,
be?
no, if it's none, which is the case where we don't have a module, then we do nothing on the execute and the call. If it's some, we put a prefix column on it, on the code before generating it. What do you think?
Mm, does that work? Does that actually work?
Ah, not
Mm,
necessarily. Because you may be inside a module, but you're doing a tail call of something that comes from outside.
yeah, no, nested modules make this a bit trickier than just doing that. When do we generate the functor table is the question.
Well, we initialize it with empty when initializing the compiler. I can tell you that much.
Ah, right, we do it incrementally, don't we?
Hmm.
We do it
And then line
incrementally.
142 adds more stuff to it.
We do it freaking incrementally. That's a problem now. That's kind of a problem now. Okay, that means actually we should. Yeah, we should add another pass to the compiler. I don't think we can escape from that.
All of that for
Because
nothing.
because we need to collect all of the names that are defined inside of the module to decide if we need to add the prefix or not, right?
I would say not necessarily. For example, if you have a name that is defined within the module and outside the module, I think there should be a natural priority system going on, like shadowing, for
Oh, you,
example.
oh, you want to add shadowing then?
Yeah,
Man, the
no,
days where Lemos is defending shadowing.
no, I'm trying to
Those
make a
days.
point because I don't want to add another pass.
Why
Uh,
not?
but this is already like this type of shadowing on modules. For example, we already did that in OCaml. I don't remember which project anymore, but we already worked with that, and it was not that worse.
That doesn't solve the problem though.
It does, because that means that you can keep doing lookups and popping the stack until you find something. So
Doing
if
lookups and popping the stack.
yeah, so you first start by the environment of that module. You try to do the find there. If that fails, you pop and you try to see the outer scope out of that. And you do that until you exhaust the stack.
That doesn't work because we built the functor table incrementally.
Ah, I see what you're saying. It's because we may not have reached a point in the program that the match will be inserted into the thing because we don't do the functor table in a single shot. We do it incrementally.
Yeah, because
I see the problem.
like if I make a dumb predicate
Hmm.
that does cons of A and B, like at this point in the compilation pipeline,
The
we
only cons that you have
haven't
available is the one
seen,
outside.
yeah, we haven't seen these cons yet. So if we try to do what you're saying, we're going to use the wrong cons here.
Yeah, Yeah, I was wrong. So we're gonna have to add another pass and fuck shadowing anyway.
I mean, we can still have shadowing, regardless of whether or not. Well, the fact that we have shadowing or not is a separate question. Like,
Mm-hmm. Okay, so we need to add. Okay, so what's the? Let me. We're not gonna do this right now because it's already late, and I'm gonna finish the recording as well. But